So let me share my screen. I need to be sure everyone can see my screen. Okay. Can you all see my screen?
Yes, I can see your screen, Mr. Usman.
All right, thank you very much. Good morning, class. So I'd like to welcome everyone to today's class. And just like Dr. Orlando rightly said the other time, I'm a practitioner in the industry. I work for government. I've been around for over more than a decade, over 15 years. My background in computer science, I have a bachelor's in computer science. And I've got my master's in information security from the Royal Holloway University of London. And currently, I'm undergoing my PhD in computer science. So I trust that all of us will all enjoy the class together. So today we will jump straight without further ado. They've done a lot of introduction about what Transformation College of Business and Technology is about. And this part of the class is Introduction to Computer Science and Cybersecurity. I'd like us to type in the chat what's all of us in the class, what's our competence level between 1 to 5 when it comes to computer science and cybersecurity. Are you new into computer science? Are you a beginner? Are you intermediate and all of that? So what's our level of competence? Just rate yourself 1 to 5. I'll go through the chat room and I'll see all that. Okay, Adekunle says 2, something, a beginner. Anastasia 3, wow, that's interesting. Abletu says 3, Emmanuel 3, Richard Oiloye intermediate. Abiodun 2/5, Sunday Jimo 2. That's great. That's great. That's great. So we learn every day, and it's said generally in the knowledge balance, learning never ends. The course outline, quickly, I'll go to the course outline. We'll be looking through computer science, computer science, and cybersecurity. We'll also look at computer science across the disciplines. Understand the history. We'll try to understand the history, classification, and global impact of computers. We'll further go into why does cybersecurity matter in our world, in the digital world we find ourselves today. Understand the concept of computer hardware and software. We will also try to understand computer data processing systems. We'll also learn how to understand the procedures for computer and data preparation method. We'll also learn to know the security and safety procedures within a computer environment. We'll also learn the concept of computer networks, the use of internet and its tools and resources, computer science, and the future of society. Computer science is very important. When you talk about information technology today, you talk about AI. I generally talk about computer science as the mother of all. So let's move to the next slide. The first thing I will look at computer science and cybersecurity. To start with, what is a computer? Generally, a computer is an electronic device. You recall in the primary school days, also in secondary school, and before the university days, they used to tell us computer is an electronic device or machine which accepts data and all of that. So they tell us so that we understand that a computer is an electronic device that processes data and performs tasks based on instructions from software programs. So computer can store, retrieve, and manipulate data, allowing users to perform various functions such as calculations, communication, and automation. Now, what's computer science? So let's go into it further. The computer science is the study of computing, focusing on algorithms and their applications. Study of computing. And that's what computer science is about. Focusing on algorithms and their applications. Our computer science is rooted in engineering and mathematics. For you to be a good computer scientist, you must understand the fundamentals of mathematics. You must understand mathematics. Mathematics and computer science are interrelated, particularly when it comes to automation, when it comes to logic, because generally we know that computer operates with zeros and ones. 0, 0, 1, 0, 0. So all of that. So mathematics is the basics of computer science. So it enables technological advancement, just what we see today, what we use computers to achieve. It impacts various aspects of our society, such as online shopping. Our phone, our mobile phone, is a mini computer. Apart from online shopping, communication, and media streaming. While computing rapidly evolves, its foundations established decades ago, and it continues to shape modern innovations. So for those of us in class, don't worry, whether you're in level 1 or level 2, you're an advanced, we're on this journey together. There's time for questions and interaction. We'll work together and ensure that we all get to the destination and we all become the gurus that we desire to be. So now, what's cybersecurity? So let's imagine we've talked about what a computer is. And imagine your computer is like your own treasure box. You know, the box you have in your house. And imagine that box with, in that box, you have your favorite games, you have your photos and secrets. Or even a box that you put your jewelries and your valuables in. And now just look like you wouldn't leave your treasure box open for strangers. Before we even talk about that, and you don't want any bad people to sneak in and take or mess up your things. So cybersecurity is like having a team of superheroes that will protect your treasure box from sneaky bad guys. Before I go further, I'd like to make a quick example. You live in an apartment, you live in a house, and the key to your house you have with you. And anytime you're about to leave your house, you try as much as possible to lock your door. And look at this scenario. On leaving your house, you just, on your way, just give your key to a stranger, or you just drop your key. Someone could pick the key up, get your door open, and take away your valuables. So if you look at the diagram on the screen, you have your computer, you have your desktop, and you have something like a padlock at the center, trying to ensure that all the information that you stored on your computer is protected. And just like it's explained, cybersecurity is like having a team of superheroes, like bouncers that you see people just, why do you want to enter this place? If you don't have access, you will not be allowed to gain entrance into a room or to a place, to an office. So imagine cybersecurity just like that. And how cybersecurity works in today. So for your mobile phones, we all have laptops, and the starting point is your password. Your password is just like, it's like your secret keys that only you and the people you trust know. And for me, for your password should just be for you alone. The password should not be shared. And without the key, no one can open your treasure box. So we're going back to that box that you so much treasure. So your password is just like your keys, the secret keys, where only you and you alone use, or something that only you're aware of it, and you use it to gain access to your mobile devices or your laptops or any other device that's smart. So on top of that, we look at firewalls. What firewalls are, these are like strong and magical walls around your treasure box. Only let friendly visitors come close. People will only come close when they've been properly screened. And that's why you call it a firewall. It's a strong wall where you screen what goes in and out of that box or that location. At the third level here, so imagine your antivirus software, and imagine a friendly robot that patrols around your treasure box. It keeps an eye out for any unwanted bugs or monsters trying to sneak in. Are we together? I want response to the chat box. I hope you're following me. So we've looked at computers, we look at what cybersecurity is, and we are at the point where we're trying to explain how cybersecurity works. So we've looked at what passwords, we've looked at firewalls, and we looked at antivirus software. So let's move ahead to computer science across the disciplines. Like I mentioned, computer science is the mother of all. In those days, in the early days, what we learn about is the use of spreadsheets, how do you write code. I remember when I was, I think quite in the late 90s and early 2000s, I wrote codes using a paper and a pen. And then we'll call it, write a line, you could write codes using paper and pen, because in those days, for you to own a personal computer, it was a luxury. We all queue into the lab. Someone must get done with the computer before you could have access to it. So that's how things evolve. But today, we all have systems, we all have laptops, we all have personal computers. So now we're looking at computer science across disciplines. So the first part of it is data science. Today, we hear a lot about data science. And generally today, we say data is the new oil. And that's the absolute truth. And let's get into it. Spreadsheets, imagine spreadsheets. We'll talk about spreadsheets. They are widely used data-centric programming tool that organizes and analyzes data visually, making computation accessible. And however, this spreadsheet, they have limitations. And you look at your Microsoft Excel, for example, even before Microsoft Excel, we've used different types of spreadsheets to make computations and to do calculations. And these limitations are row limits, data loss risk, and lack of enforced data types, and which could lead to errors. And as seen in the UK COVID-19 case misreporting in 2020. But looking into, as we make progress, we generate loads and loads of data, volumes of data. So for large-scale data analysis, spreadsheets are insufficient. And this is leading to the rise of data science, and which is a field that combines computing with data analysis to extract insights. And for us, for lovers of football, you know today that a player, you could look, the field of the data science or data analytics is been able to help us to be able to determine how accurate how skillful a player is, the number of passes, the number of assists, data. With the power of data, we've been able to achieve this, and among other things. Even in the business world, data has been able to help to be able to say, okay, do a forecast to say, okay, what is the level of production assists? How are we satisfying our client, our people, and what do we need to do? So through data, you're able to get all of this to be able to provide insight into what you do, and it also help you to make better decisions. So the data scientists analyze big data using ML, which is machine learning, and a subset of artificial intelligence, and which enables computers to learn patterns. ML is applied in various areas such as fraud detection, targeted advertising, and customer behavior analysis. Another area is computational science. And what's computational science? Computational science applies computing to advance scientific research and practical fields like engineering, finance, and medicine. So with the power of computers, with the power of computing, we're able to advance research in finance, particularly when it comes to investments, risk-taking. We're able to apply computer science. And that's why there's a field called financial engineering, which is some sort of an area in finance that you need to apply a whole lot of computing and put in research. Also medicine. In the area of medicine, systems have been developed through research in computing to advance, to be able to detect a lot of solutions that could treat a lot of research in medicine generally, which we'll get into as we make our progress in this class. So through computational science, it enables innovation such as numerical weather prediction, which uses mathematical models to forecast weather and study climate change. So all of this has been able to be made possible with the power of computing and computational science. This is achieved through systems where the power of this requires significant computing power, which is sometimes distributed across multiple computers. So what are we trying to say? To be able to achieve all of this, systems have been developed, algorithms are being developed, and through some sort of interconnectivity to enable the solution to be achieved. So in summary, computational science focuses on developing efficient methods to implement these complex algorithms and software solutions. Before I leave this slide, I would like to explain that for you to be able to develop a model to solve a particular problem, whether in engineering, finance, and medicine, you must understand what an algorithm is. An algorithm basically is just a step-by-step. Look, say for example, you want to cook a meal or you want to cook a soup. So first thing first, you need to go to the market, you need to buy these ingredients, and when you come, you need to prepare the place, you need to mix the stuff, and you need to put it on fire and begin to stir it until you get your desired point. And basically, it's just a step-by-step approach to achieve a particular task or achieving or to solve a particular problem. And when you're able to do that, and then you flesh it up through different codes, different languages, and then you turn into the solution that you want to achieve. So looking at this slide, you'll see how computer science has been able to help in solving or addressing climate change issues. And this limits the impact of climate catastrophe by enabling technology. So technologies is used to ensure for decarbonization through power consumption, optimization, and advancing renewable energy sources. And just like today, renewable energy is at the forefront, and all of this is made possible by the power of computing and basically the power of computer science. Okay, so I'll take that. Please, I'll take that when it comes to question session and keep that coming. Thank you very much. So numerical weather forecasting not only support our everyday life, but also helps climate scientists determine the precise location for wind turbines and similar. So all of this is made possible by the power of computer science. Also, to support the power grid, data science methods help predict peak power consumption, optimize power sources to produce exactly the amount of power that is needed. So through computer models and algorithms, it also assists energy engineers in optimizing building air conditioning and power demand so that they efficiently serve the people living, working, and playing with them. So what I'm trying to say, that building models and through system development could help us address the day-to-day problems, could help us address the challenges we face on day-to-day basis, from power to climate change, and the list is endless. Information science. So remember, I've talked about data science, computational science, and now we're talking about information science. So computation and information science are increasingly integrated across various disciplines, from biology to social sciences. So it tells you that the relevance of computer science to all fields of study. The Nobel laureate David Baltimore described biology as an information science, highlighting DNA as an encoded set of biological instructions. Information science originally focused on organizing and managing information in libraries, which now spans various fields like physics, chemistry, economics, and social sciences. So David Baltimore described biology as an information science and highlighting the DNA as an encoded set of biological instruction based on his research. So information science originally focused on organizing and managing information in libraries, which now spans various fields as mentioned. So in the world of today, the world we find ourselves, social media plays a significant role in how people engage with and understand information. And I know all of us here, we use social media. You could see the power, the way, the flow of information today through trending news. Somebody will just post something, and before you know it, 1,000 likes, 3,000 likes, and on and on. So this is made possible through the rise of information technologies about internet, which carries risks and experts in field of information, data science, and computer science. And like I said, computer science bears social responsibility to ensure these technologies are used responsibly, acknowledging the consequences of both successes and failures. So the whole idea is the information flow today is also made possible by the rise of computing and information technologies of internet and all of that. But as the point here is, as aspiring computer science experts or computer science practitioner, while we use this technology, we must also ensure that we use the technologies responsibly, because for us to use technology to address our issues. It has its merits, it has its demerits, and technology has its benefit. However, we must ensure we use technology responsibly. And that's an important aspect today that we emphasize as professionals and practitioners, because there are risks associated with it. We must ensure we use technology responsibly. We must use it for the benefits, for our benefits and the benefits of our world, and also ensure that we manage the associated risks that come with technology. So looking at this survey as well, we'll talk about, and this is speaking to the percentage of US adults, United States adults, who get their news from social media. Like I said, despite the centrality of information to decision-making and social change, dominant approaches to computer science tend to focus on computational structure, systems and processes such as algorithms that describe one kind of information. By focusing on
Sorry, we apologize for the glitch. I think he is still on the call, so obviously Mr. Usman is trying to get back on. So please do bear with us. I mean, these things, we don't have control over these, but I know he will get back shortly.
Can you hear me now?
Yes, can hear you.
And can you see my screen?
Yes,
Not
we can
yet.
see your screen. We can see your screen.
Okay. I guess others can see already.
Can you confirm again? Can you see my screen, please?
Damola, can you still see the screen? Because I can't see.
Yes, I can see the screen. I can see your screen. I can see his face right now. Yes, exactly.
Okay. I hope every other person, please, every other person, I hope you can see his screen. Please indicate in the chat room so we can continue.
Can you indicate in the chat room
Sir, I think you should just stop sharing and start sharing because I can't see your screen either.
Okay, good. So please, Mr. Usman, you can stop sharing and reshare so we can all see your screen.
All right, I'll do just that. So can you see my screen now?
Yes, I can see your screen clearly. Computer science.
The computer science and interdisciplinary field. Apologize for that break. Okay, all right, thank you very much. So like I said, we've talked about the application of computer science in various fields, and the point at which we are now is the computer science is an interdisciplinary field which explores the expansive nature of computer science and its role in shaping various fields in data science, computational science, bioinformatics, and information science. It highlights the challenges of defining computer science today as it is applied across the world in diverse ways. While computer science traditionally stemmed from mathematics, which I mentioned earlier, it is now widely recognized for its intersections, the real-world problems involving artificial intelligence, AI, machine learning, ML, and human-computer interaction, HCI. Computer science subfields are categorized into three main areas. One is a theoretical computer science, where we talk about theory of computation, information representation, data structures, and algorithms. For you to be a good computer science student, you must understand data structures and algorithms. So the fourth part is programming language and formal methods. And for programming languages, we have low-level languages, high-level languages, and object-oriented programming languages. So we'll talk about that in the future. So the second subfield is computer science, computer systems rather, where we talk about computer architecture. How does the computer, how was it designed, the internal structure of a computer? The second aspect is the artificial intelligence. The third is networks. The fourth aspect is databases. The fifth, under the subfield of computer systems, we have distributed computing. And the last but not the least, under that category is graphics. The third subfield of computer science, which is applied computer science, we have scientific computing, human-computer interaction, and software engineering. These are the three subfields of computer science. It is important to put this across, that these subfields are treated separately. Various texts argues that human-computer interaction should be infused throughout all of computer science, as real-world problems often involve intersection of technology and people. The problem we face in the world today, only technology cannot solve the problem. People, it has to involve the intersection of technology and the people, and in fact, process. And that's why generally we talk about people, process, and technology. For instance, AI and machine learning directly affect human decision-making with application in areas like advertisement targeting, language translation, and autonomous vehicles. A lot of us today, we are one way or the other, we've used a lot of AI tools and software to carry out the day-to-day activities, things we do every day, our jobs and all. So furthermore, the text emphasizes the importance of integrating computer science knowledge with other domain expertise. For example, weather prediction, which combines computer science with climate knowledge. So all of this was saying is you must have the domain knowledge. So what this is trying to say is, in the future, even now, different field of study, experts in various field of study coming together with experts or students or researchers in computer science will have to come together to solve real-world problems. Your knowledge of computer science, your climate knowledge, or your knowledge of environment. How do we make our environment better? Or your knowledge of energy production or renewable energy, and your knowledge of computer science will have to work together. So we're in a world now that collaboration is the key word. We can not stay in our corner or in our own area, that this is my area, but we all have to work together to ensure that we live in a world where that is freer, that is safer, and that is smarter. And all of this would work better, would not be able to achieve any of this without the knowledge of computer science that we're talking about. So theoretical computer scientists are also focused on complex questions about fairness and encoding of ideas in data and the limits of computational approaches. Also, ultimately, the text underscores the importance of interdisciplinary collaboration, and that's what I'm talking about in computer science, as it greatly amplifies the field's impact on society. Now, understanding the history, classification, and global impacts of computers. So the history of computer. For us in computer science, we take history very seriously, because if you don't know where you're coming from, you might not know where you're going to. So history of computer, the earliest computing devices like the abacus were used for basic calculations. And over time, advancement in number systems and algorithms improved computation. In 1614, John Napier introduced logarithms. If we are a student of mathematics, we know what logarithms are. Simplifying complex calculations. And in the 1820s, Charles Babbage developed the difference engine and later the analytical engine, with Ada Lovelace pioneering programming through punch cards. By the late 1800s, Aman O'Leary created a punch card machine for the US Census, influencing early mechanical computing. The early 1900s saw widespread use of calculators and adding machines. By the 1940s, computers like IBM's Harvard Mark I emerged, paving the way for modern digital computers in 1950s, revolutionizing technology. In brief, this is the history of computer, right from the earliest computer devices, abacus, to today's digital computers. Let's also look at this woman, a Black woman. A Black computer scientist recalculated the computations done by early digital computers for space flights at NASA. Our contributions were portrayed in the book and the movie, Hidden. So she's one of the people, Katherine Johnson is one of the people that contributed to early digital computers for at NASA. That is for space. So to tell us how we can apply the power of computing and computer science in the use of space. And today, more of that is being used at different level. So this slide shows us, we're talking about the punch card machine and the analytical engine. You can imagine all of this is revolutionized today into what we have in our hands as mobile phones and our personal computers and all of that. So technology has evolved and is evolving, and it will continue to evolve. And we must not be left out. And that's why we're doing this, to say, we need to build people, leaders and innovators that will take our world from where we are to where we need to be. So having said that, so we also look at classification of computers by generation. We had first generation computers from the 1940s to 1956, which is the vacuum tube computers. Second generation, 1956 to 1963, transistor computers. And the third generation, the 1964 to 1971, integrated circuit computers. And fourth generation computers, 1971 to the present day, microcomputers. And the fifth generation is what we have in the present and beyond, which is the artificial intelligence computer, the AI computers, which is, no one knows this is the destination. Technology keeps changing by the day, and we must not sleep on anything. We must continue to research, get information to ensure that we stay ahead and we are aware. Why does cybersecurity matter in our digital world? Why do we need cybersecurity? And the first reason why cybersecurity matters is about protecting our personal information. Like you said, cybersecurity matters because it acts like a lock on your digital house. We described the other time, it's just like the key to your house or your secret code to your treasure box. You don't want someone to know the code, because I tell people, your friend today might not be your friend tomorrow. Let me give you a quick example. I had an experience so many years ago where two friends, they were friends, they work in a bank, and one day one of them was going to the restroom and left her computer open and said, okay, I'll be right back. And she didn't lock her computer. And her friend just quietly walked into the system and typed a resignation letter that I hereby resign from the services of the bank, blah, blah, blah. And that mail got to human resource. And what will happen? And when you resign such an organization, someone will call you, they will invite you for an interview. Oh, why are you leaving the bank? What happened? They will do what they call an exit interview. So before we knew it, it took a lot of intervention to say, oh, I didn't send this message, I'm not the one, and all of that and all of that. And the friend that did that thought that was a joke. It wasn't a joke at all. So the same thing could be you as a person, you're on leave or you are not available. You say, okay, oh, take my ATM card and go to my bank, withdraw some amount of money. This is my PIN. So all of this, we need to be very careful. We need to be wary of that, which it should be known to us and all that. You protect your valuables, you protect yourself in the digital world. Just like even on social media, we must also protect our account. We must ensure that we protect our passwords, our personal information. We don't share our personal information like photos and emails, even our bank information. We must not overshare. We must ensure that we only share what is required. So every day we use our computers, we use our phones. Cybersecurity ensure that this sensitive data stays private and safe from people who might want to steal it. Are we still together? Hello? Yeah, good.
Go ahead. Yeah.
All right. So the second aspect where cybersecurity matters is
Yes, we can hear
safeguarding.
you.
All right, good. Safeguarding our financial assets, like our online banking, shopping, and investment. All of this happen over the internet. In fact, beyond this, we even buy food. We order what we eat today through our mobile phones, our internet, our apps, and everything. So, and all our life is already out there, our financial transactions and everything. So, strong cybersecurity measures is very important to help keep your money secure by preventing unauthorized access to your financial accounts. So, the third aspect is keeping business and services running. Many businesses, hospitals, schools, and government rely on computers and networks to operate smoothly. A lot of schools now, they do online exams. Secondary school, yes, primary school, secondary school, they do online exams, and all of this needs to be protected. And all of this happens through systems, computer networks, whether through your local area network or the internet or wide area network. So any attack on this system can disrupt services. And apart from disrupting services, it could cause reputational damage. I could recollect an incident that happened in the UK. That was during COVID, and a lot of patients lost their life. Like in the UK today, if there's no power for 10 minutes, there'll be a problem. A lot of people die because everything is automated. Systems, services, emergency services in particular. So imagine an attack on an important system that is life-saving. A system that must run 24 hours, 7 days, 24/7, there'll be a problem. So in essence, all of these systems must be protected, must be designed in a way that intruders, invaders, hackers, or attackers that prevented access into such systems. And when businesses are attacked, it will not only disrupt service, like I mentioned, it will also affect their reputation. It could, and also, like I mentioned, it could cause financial losses and also put life at risk. So cybersecurity is important to maintain the smooth operation of vital services. Also, preventing cyber attack, and that's one of the reasons why cybersecurity matter. Hackers and cyber criminals are always on the lookout for weaknesses in digital systems. Say, for example, a system that is open, a system that when you buy a new computer or a new system or a switch or a router, and you're using a default password, like password 123, anybody who gets in that system and break into it. So it is important that cybersecurity is in place, which involves creating robust defenses like strong password, firewalls, and encryption. This will make it harder for bad actors to break in and cause harm. And finally, on that, is ensuring trust in the digital world. We all need to trust that the digital tools we use are safe. The platform, our online platforms, our banking platform, or our computers we use, any digital tool that we use, we must ensure that they are safe. People must be able to trust that those platforms are safe. So when companies and government invest in cybersecurity, it builds trust majorly among users that their data is secure and the online services they rely on are reliable. These are one of 5 major reasons why cybersecurity is very important. Protecting personal information, safeguarding financial assets, keeping businesses and services running, preventing cyber attacks, and ensuring trust in the digital world. Let's use this analogy again for us to understand the concept of cybersecurity that we're trying to emphasize. Imagine your computer is like a treasure box at home. Your personal photos, your messages, and important documents are the treasures inside. Cybersecurity is like having a strong lock on that box. Alarm systems and even neighborhood watch members will help keep treasures safe. Without these locks and alarms, anyone passing by could sneak in and take or damage your treasures. That's why cybersecurity is so important. It helps keep everything safe and secure in our digital world. In short, cybersecurity matters because it protects our personal data, our money, and the systems we depend on every day, ensuring that we can enjoy the benefits of technology without fear or harm. But before I leave this slide, I would like to also say that imagine before we go into the digital world, our world has been physical. We share papers, we send letters, we write letters. Imagine in those days where we actively make use of post offices. Then I know in the late 90s and early 90s, late 90s, if you are around, then you write JAM or you write the WAEC or just any exam, then you have to go to post office to pick up your results. It's sealed. Why do they seal that? That seal is a form of protection. And when you even go to your box, each box is unique to a user. And when you go there, it's that you get your key or you put a code to ensure that an unauthorized person or individual do not have access to that letter or to that result or to that document. Are we together? So this aspect is very important for us to understand. And while we now move from there, we now move to email, where, okay, we all now receive our notification of results via email. You could now register for your exams online, and you now have a unique identity. That could be your username. It could be a unique name or your email address, and you have a password that is given to you, which is unique to you. So this is understanding. So moving from the physical world now to the digital world. So now in the digital world, we now talk about encoding and encryption. So all of that now replace the seal that we put on our document. So because before you could open it, you have to go through a lot. And in the physical world, you know that that letter or that document is taken from the sender to your location. You are the receiver, and your address is on that letter. So that address, physical address in the physical world, is now taken into digital world as what? Your IP address, which we'll talk about as we make progress. So it's important that as we move from the physical world to our digital world, cybersecurity is so important. It helps us to keep everything safe and secure. And it also helps us to enjoy the benefits of technology without fear or harm. Now we look at classification of computers. Types and classes of computers. Computers can be classified based on their purpose, size, and processing power. Below are the main types and classes. Classification by purpose. Like I said, computers are classified based on purpose, based on size, and processing power. Classification by purpose. One is the general purpose computers. These are computers that are designed for multiple tasks like gaming, web browsing, office work, and programming. Examples are personal computers, our PCs, and our laptops. Number two is the special purpose computers. They are built for special tasks such as scientific simulations, military applications, and industrial automation. Are special purpose computers. Example are supercomputers and embedded systems. So classification by size and power. One are supercomputers. They are fastest and most powerful computers. They are used for complex simulations, AI research, and weather forecasting. To recall the other time we talked about the power of computing. And all of this is achieved through the power of computing, building models, maths.
So, hello, sorry for the break in transmission. I think the network is a little bit bad, so let's just give him a minute and hope he comes back to the team. We're so sorry about the network issue. These are kind of things that happen that we're not in control of, but I know shortly everything will be in order.
Damola, he is back online. Please make him a co-host.
Okay, I'm on it right now.
Damola, please hurry up with that. Make him a co-host. Goma.
Sorry, ma'am, we're having a little bit network issue, but it will be done in a few seconds now.
Yes, Damola, what's going on? Okay. Mr. Usman, I think you've been made a co-host. You can continue, please.
All right. Thank you very much. I apologize for that break. I just noticed I was talking and I couldn't get. So perhaps I'll have to go back to slide 25, if that's fine, on that classification of computers. Let me share my screen quickly again. That's also the challenge of technology in this part of the world. All right, so like before we had that break, I was talking about classification of computers, computer classification. And I quite mentioned that computers can be classified based on purpose, based on size, and processing power. And I mentioned that below are the main types and classes. Classification by purpose, we have general purpose computers, which are designed for multiple tasks like gaming. For those of us that are gamers, web browsing, office work, and programming. So these computers are personal computers and our laptops. They don't really require much to carry out those tasks, except you need to upgrade them, their memory or their capacity or the storage. So the second classification by purpose is special purpose computers. These are computers that are built for specific tasks, such as scientific simulations. This could involve you modeling that, and there are special purpose systems. You want to carry out a research, you need to model, you need to combine a lot of systems together to achieve that purpose. So military applications or industrial or automation. Examples are supercomputers and embedded systems. Classification by size and power. We have supercomputers, which are the fastest and the most powerful computers. They are used for complex simulations, AI research, and weather forecasting. These are systems that high-end systems that their computational power and the speed is very important when it comes to this kind of computers. So they must also be very fast, and their computation power must also be, and also their memory too. It has to be very high when it comes to supercomputers. And also, under that, we also have the mainframe computers. They are large, powerful systems used in banks, government agencies, and large organizations because they process large amount of data as well. Most government agencies and banks, because of the nature of customers and the nature of services that they provide. So examples of these mainframe computers are IBM Z series and UNIVAC. The third in that category is mini computers, which could also be referred to as mid-range computers. These are computers that are smaller than mainframes, but still handle multi-user tasks. They're used in business applications and manufacturing industries. PDP-11 is an example, and IBM AS400. So microcomputers are personal computers, which we call PCs. Includes desktops, laptops, and smartphones. They're used for personal and business tasks. Examples, a lot of us have most of these with us, Dell XPS, Apple MacBook, Lenovo ThinkPad rather. So the fifth in that category is the embedded computers, which are built into other devices for specific functions. They are the ATM machines that we are used to, the ATMs rather, smart appliances, and medical devices. Example are the microcontrollers in cars and Raspberry Pi. So ATMs too, they are embedded computers, because basically when you interact with them, you need to punch this, you need to provide your code, you need to provide all of that. So they are also computers. And also the smart appliances we have in our various homes and offices as well. Global impact of computers. Excuse me. The global impact of computers has been profound, influencing nearly every aspect of our daily life. Here are some of the key areas where computers have made significant impacts. One is communication, instant communication, like our email, instant messaging. Email, we're familiar with that. Our Gmail, our Yahoo Mail, our different categories of email, our Exchange, and all of that. They are used for instant communication, and this has been made possible through the power of computers and computing instant messaging as well, like chat boxes that we have. I remember, I know I've used Lotus Notes, which is used for instant messaging. That is used. Most of all of these are used in corporate environment and business environment as well. Example, like I said, Lotus Notes by IBM. I also know that there is Microsoft Link by Microsoft, and a few other ones. Video conferencing, the one that we're using now, like Zoom and the rest of them, they have revolutionized how people communicate, making it faster and more efficient. A lot of us have joined us from different parts of the country, perhaps a different part of the world, and we're making this happen. Unlike before, we have to travel a long distance before you could get. So this is the power of computers. And that's why you count yourself lucky. You are in the field of computer science. You should be glad that you are, and you must make it count. Social media, platforms like Facebook, Twitter, and Instagram have transformed social interactions and information dissemination. In those days, before now, so many years back, we'll listen to Tales by Moonlight. People sit around, we have to just tell stories in the villages. People gather in the evenings to chit chat. But today we'll create different communities online to the power of social media, and it also has transformed social interactions and information dissemination. However, it has its benefits and demerits as well. So education is another impact, the global impact that computers have actually brought to the world. E-learning, and that's what we're doing right now, is learning now is everywhere. Through online courses, educational resources, learning more accessible to people worldwide. Research, computers facilitate data analysis, simulations, and access to vast amount of information, which enhancing academic research as well. Okay, medical records. Electronic medical records improve accuracy and accessibility of patient information. In advanced countries, when you visit any hospital or medical facility, you just need to provide a code. Just provide your name, either your first name or last name. Every of your information would be available. Your last visit, the state of your health, your ailments, and the kind of treatments they've given you in the past. And I know in this part of the world as well, with a lot of hospitals and medical facilities, they've embraced electronic health record management systems, and which are also improving by the day. And this also tells us why we must also secure these systems in the impact. Despite all of these benefits, we must also secure them to ensure that we build trust. We must also build trust in those systems. Remember when we talked about the last time about trust, why cybersecurity matters, to ensure that we improve trust in our digital world. Another aspect is also treatments and diagnostics. So advanced imaging technologies, robotic surgeries, and AI-driven diagnosis have improved healthcare outcomes. Another area is the business and economy. Automation, computers have automate routine tasks, increasing efficiency and reducing costs. E-commerce, online shopping like Amazon, Alibaba have transformed retail, enabling global market access. The fifth one is the science and technology. Research and development, computers are essential for simulations, modeling, and data analysis in scientific research. Innovation, they drive advancements in fields like AI, biotechnology, and nanotechnology. So the global impact of computer can never be overemphasized, is highly appreciable, and it's something that is really valuable, and it's changing our world very fast. Entertainment, we can all attest to that. That mobile phones will download games, music, movies, will share all of that. And the major one today in the media, streaming services like Netflix and Prime, Spotify have changed how we consume media. So as an innovator, as an aspiring innovator and as an aspiring leader in the area of computer science and core computing, what would you do to change our world? And just look at it, transformation college. So that's what will you do differently to change our world? So 7 aspects is government and public services, e-government services, for tax filing, e-voting, public information have made government operations more efficient. Globally, this is what's happening. And also in this part of Nigeria, it's also not left behind in all these aspects, particularly when it comes to tax filing. The e-voting was not there, but I'm sure that moving, but a lot of other places in the world have also embraced e-voting. Public information also is being made available through social media and through various platforms. As security, computers are crucial for national security, no doubt, including surveillance, cybersecurity and defense systems. Transportation, navigation, GPS technology have revolutionized travel and logistics. Autonomous vehicles, self-driving cars, and drones are becoming a reality. They are around us. We still work, and they are working, and more transformation is coming. So there are also which promises to transform our transportation and the way we move from one location to another. Environment, climate modeling. Computers help in predicting climate changes and developing strategies to mitigate environmental impact. Resource management, they optimize the use of natural resources through data analysis and monitoring. Just like our environment, through analysis, through monitoring, through modeling, we can monitor our environment to check what's changing, what do we need to improve, and all of this is made possible through the power of our computer. Social impact, digital divide. While computers have brought many benefits, they have also highlighted inequalities in access to technology. Privacy and security. The rise of computers have raised concerns about data privacy and cybersecurity. And data privacy is a big deal today, particularly the GDPR and the General Data Protection Regulation, and also the NDPR, National Nigerian Data Protection Regulation as well. So privacy and security is a major concern, despite all of these advancements in technology, accessibility, ease of use, and everywhere being a global village. Data privacy and cybersecurity is a big concern to ensure that while we consume all the benefits, how do we protect our society from harm? Cultural impact, globalization as well. Computers have facilitated cultural exchange and globalization, making it easier to share and access cultural content. The world is a global village. You want to learn a new language, you want to understand, you're moving to a new environment. You need to understand their culture. All of this has been made possible through the power of computers. So digital art, new forms of art and expression have emerged through digital media and software as well. So work and employment, remote work. Computers enable remote work, changing the traditional workplace dynamics. A lot of people now, you'll recall the other time, Dr. Lando emphasized the fact that it's not only about your education, whether you have a bachelor's degree or you have a master's degree or a PhD degree, you have skills. The world is about skill. And when you have skill, you are a global expert, you're a global champion, you're a global citizen rather. So you have access to remote work, and there are a lot of platforms. They are all there. From anywhere in the world, you could work. So job displacement, automation, and AI led to job displacement in certain sectors while creating new opportunities. A lot of people say, oh, will AI take over our jobs? Absolutely, will take over some jobs, to displace some jobs, but it will create more opportunities. Definitely. Finance, online banking. Digital banking services have made financial transactions more convenient. From the comfort of your home, you could do thousands and thousands of transactions from your mobile device, from your app. Everything is done from there. From creating your bank account to carry out your transactions. All of this is made possible by the power of computers. cryptocurrency, the rise of blockchain technology and cryptocurrencies like Bitcoin has introduced new financial paradigm. You all agree with me. Legal and ethical issues, IPs, intellectual property issues. The teacher is as complicated issue of copyright and intellectual property. It's very important because all of these is easy to find out and detect intellectual property issues. Cybercrime. The increase in cybercrime poses significant challenge just for law enforcement and legal systems because of the rise in the issues of cybercrimes and cross-border transactions and all of that. If you commit because of the internet, if you commit a crime via the internet and your systems, except that computer is unplugged from the network or disconnected from the internet, in as much as that computer is on the internet, it could be discovered from anywhere in the world. I tell people, except you take your computers and put it into the wall, that's when that computer will not be reached. You break the wall open and you steal the computers. But in as much as that computer is connected to the internet, it could be reached from anywhere in the world. And that's why we're emphasizing that cybersecurity and from putting those measures in place, ensuring that you put a proper password, you have firewalls, and you put antivirus software, ensure that your system, the software that runs on your system is up to date as much as possible. And also global collaboration, open source platforms like GitHub have enabled global cooperation on software development. So, and for all of us as we make progress, so GitHub is a platform where you could be there, join, and it will help you to also collaborate with other developers when it comes to software development. Crowdsourcing. Computers facilitate crowdsourcing for various projects, from scientific research to creative endeavors. So I think at this point, before we go further, should we take questions? I'm thinking after the break, when we come back from the break, we'll take questions first, and then before we move into other concepts. Is that okay? So that I could go into the next concept, or you want us to take questions now?
Mr. Osman, I think your suggestion is very, very okay. Please go ahead, sir.
All right, thank you. So after break, we'll just take questions. Thank you very much. So now we'll move to the understanding the concept of computer hardware and software. So we'll talk about what computer is able to do and the benefit and the impact of computers. But what is inside the computer itself? And as we've been as an expert, we must understand how does this computer work? Before you be able to create any form of innovation, you must understand our computer. And so that's what we're going to do next. So what hardware? And hardware refers to physical components of a computer system that enables it to function. Unlike software, which consists of programs and instructions. So the whole idea is software or programs runs on the hardware. And that makes up what we refer to as the computer. So hardware includes tangible parts, such as the processor, the memory, storage, input and output devices. Now we talk about central processing unit, which we all call the CPU, and is often referred to as the brain of the computer. The CPU performs the majority of processing tasks. It executes instructions from programs and perform calculations. So what are the components of the CPU? One is the arithmetic logic unit, the ALU, which performs the arithmetic and logical operations. We have the control unit, which directs the operation of the processor. And we also have registers, the small, fast storage location within the CPU that used to hold the data and instructions temporarily. So that's that about the CPU. Now the motherboard, this is how the motherboard looks. I remember in the early 2000s, and then we'll travel from different parts of the country, from Ibadan to Lagos, from Lagos to Ibadan to assemble, people assemble computers in those days. From the motherboard, the keyboard, everything. But now that's no longer available. You'd rather just get your laptop and get working. Because if you need to assemble a computer, you also need to buy the UPS and all of that, but to ensure that you keep working when there's no power. So this is how a motherboard looks like. And what's the function of a motherboard? It's the main circuit board of the computer that connects all the hardware components that we talked about earlier. It allows communication between the CPU, the RAM, that is the random access memory, storage devices, and other peripherals, like your keyboard, the speakers, the joystick, the external storage, and all of that. So the motherboard is the main circuit board of the computers that connects all the hardware components. So what are the components on the motherboard? We have the sockets, which is for the CPU and other chips. We have the slots, where we put our RAMs, and expansion slots is where we put the RAM is memory cards, which enable the system to work faster for the layman. Connectors for power supply, storage devices, and peripherals. Random access mode, this is how they look like. So the RAM, they usually fixed on the expansion slot on the computers. So the function is that they provide temporary storage for data and instructions that the CPU needs while performing tasks. It's a volatile memory, meaning that it loses its data when the computer is turned off. So RAM is a temporary storage for data and instructions that the CPU needs while you're performing the task, while you're providing inputs to the computer via the keyboard, and while you get the output through the screen. So what are the types of RAM? We have the DRAM, that is dynamic RAM, commonly type used in personal computers, and static RAM, faster and more expensive, which is used in the cache memory. So the four storage devices. Function: store data permanently or semi-permanently. Types are the HDD, the hard disk drive, solid state drive, optical drives, and USB flash drives. I'm sure a lot of us are familiar with the portable flash that people still use, flash drives. They know I discourage the use of flash drives a lot because of viruses and all of that, Trojans. Because when in the era of cybersecurity today, using external drives like this flash drives could affect your computer or your system with Trojan or viruses or worms in any way. So we must be careful when we use these drives. So these are the drives available. The hard disk drive, majorly every system comes with a hard drive where you store data on it. And also solid state drive, which uses flash memory for faster data access and reliability. Or optical drives. It's been a while. I don't know whether people still store data on CDs and DVDs today. I remember then when we when we used to move to couple systems together, you could just go about with your optical drive, help people to install Microsoft Office. That was a job then. That was serious, and then you make cool money. So, oh, you need antivirus, let me install it for you, and then you go away. So people are not careful. People are not really concerned about, is it a genuine software? What's important is, oh, you have Office, you just install it and it's working and it's working. But today we are not only concerned about it's working, is it secure? It's very important. Apart from all the system, and also a lot of people in computing or software development today, or developers generally, only look at the side of, I've been able to put this code, I've been able to run this code to solve this problem. Oh, it's working, it's working. Is it secure? How is it deployed? So all of that. So as you're looking at usability, you must also ensure that you consider security, because to ensure that you'll be able to develop or deploy a system that is reliable, you must ensure that such a system is secure as well as is available, rather. The 5 is the power supply unit, which its function is to convert AC power from the wall outlet into a DC power that the computer component can use. It supplies power to the motherboard, the CPU, and other components. And that's the power supply unit, which is also one of the outlets on the motherboard. 6 is the graphics processing unit, which handles rendering of images, videos, and animation. So there are also graphic cards that could also be installed on the motherboard to ensure to process high-end graphics, images, videos, and animation. So it's crucial for gaming, video editing, and other graphics intensive tasks. So there are 2 types of the GPUs: integrated one, which is built in the CPU or the motherboard, and also the discrete GPU, a separate card with its own memory, offering higher performance. So it depends on the requirement of such a system, and that will determine what type of GPU that will be installed or that will be used on such a computer. Input devices, which these are devices that allow users, you and I, to interact with the computer and input our data. Examples are the keyboard for typing text, the mouse for pointing and clicking, and also the scanner for digitizing documents and images. Microphone also for audio input. Number 8 is output devices, which display or output, which carries out the display or the output function. So the display or output data processed by the computer. Examples are the monitor, which you often refer to as a screen, which displays virtual output, and the printer, which produces hard copies of documents, and our speakers, which output audio. So all of these are the components when you talk about hardware. So now we talk about computer software. So computer software, basically, like I said, it runs on the hardware, and the hardware will be like a dummy without the software. So they complement. So software complements the hardware in a way. So computer software is a collection of programs, data, and instructions that tell a computer how to perform specific tasks. It is categorized into 3 main types. We have the system software, we have the application software, and programming software. So the system software is, the examples are the operating system, like the Windows that we know, the Microsoft Windows that we know, the Mac OS, and the Linux. And utilizes that they utilizes the managed hardware and utilities rather. So system software includes operating systems and utilities. So let's take note of that. So utilities, so operating systems are Windows, Mac, and when you buy a computer, the Python, oftentimes it comes, the majority of the time it comes with the OS. And also the software utilities that manage hardware and provide a platform for other software. Those utilities are also, they are core, they are integrated into the hardware. Let's look at it like this. Your motherboard, they have integrated circuits, and they have different components that within them, there are also some sort of utilities that manage them, and they also provide platform for them to communicate with the software that you installed on the system. So the second category is the application software. These are programs designed for end users, so that the web browser, your word processors, your games, and the media players. The third is the programming software. These are tools used by developers to create software, including compilers. And compilers are used to compile programs or codes. So let's leave it like that for now. Text editors and debugging tools. So all of this, they are used by the developers to create software. Software enables computers to function and perform tasks ranging from basic operations to complex computations. So generally, so in summary, computer software are system software, application software, and programming software. So I call it SAP, like SAP. So you can just take on that code for it. SAP, system software, application software, and programming software. So for every system, for every computer, you must first of all install your basic operating system, whether it's a Mac, so it's there. So on top of that is when now you have your web browsers, like your Internet Explorer or your Edge and all of that. So, and your word processors, your Microsoft Office, your Excel, your PowerPoint and rest of them. So games and your media players. So, and I also talk about programming software, which are used by developers. It could be Visual Studio and the rest of them. Understand computer data and processing systems. I want to suggest, is it a good time for us to go on break? Hello? Is it a good time for us to go on break? Can you hear me?
Yes, I can hear you, Mr. Usman. Can you hear me?
Yes, I can. I said, is it a good time for us to go on break?
Okay. Can we take the break at 12:50 to 1:30? Is that convenient for you, given the number of slides? I know we're supposed to go on break by 12:30.
So this is 12.
Yeah, this is
12:20, right?
Yes.
So we
Would
can
it be
also
convenient for you?
we can use it.
Would it be convenient for you if we go by 12:50 and come back 1:30?
Okay. I was rather suggest we go. Let's go by 12:30, please.
Okay. All right then. Then if we go by 12:30, then we come back by 1:30.
It's fine.
Or rather, okay. Okay. All right, that's fine. Thank you.
So now we'll go to the next concept. We'll talk about understand the computer data processing system. So we'll talk about what are computers, the classification of computers. We've also looked at what are the components within a computer system, the hardware and the software. And we've looked at the various hardware components, and we've also looked at the application. We look at the software itself. We look at the system software, the application software, and the programming software. So now, what we want to try to understand computer data processing systems. A computer data processing system is a combination of hardware and software that processes raw data into meaningful information. It follows a structured approach to handling data and ensuring efficiency, accuracy, and automation of tasks. So what are the components of a data processing system? A typical data processing system consists of 1, input devices, which captures raw data through our keyboard, our scanners, and our sensors. 2, the processing unit, execute instructions and manipulates data. 3, storage devices store data permanently or temporarily, which we'll talk about earlier. The output devices present processed data as information, and software manages processing and execution of tasks. Now I want to talk about data processing cycle. This, I'd like all of us to pay attention at this point. A data processing system operates through a cycle consists of data collection, input, processing, storage, output, and feedback. Again, data collection, input, processing, storage, output, and feedback. So data collection is about gathering raw data from various sources. And we talk about different data sources. Data sources could be internet, social media, could be from physical documents, could be different sources of data. So you gather all of that. And then the input, entering the data into the system via the input devices, whether through the scanner or through the keyboard. Processing now, using software and hardware to manipulate, analyze, and transform the data. And a lot of tools available to do that. Storage, saving processed or raw data for future use. Output now in printing results in a usable format. And that format could be in a graphical format, it could be in different forms, images, and providing feedback, evaluating output for accuracy, and making corrections if needed. These are the processes that involve in the data processing cycle. So what are the types of data processing systems? We have batch processing, real-time processing, distributed processing, cloud processing. The batch processing is where data is collected and processed in groups at times that are scheduled. You put information together, and a critical example is the payroll system. You process, say, salaries, for example, in batches at specific times. So real-time processing. Data is processed immediately as it's entered. Online banking, ATMs. Distributed processing. Multiple computers share processing tasks over a network. Cloud processing. Data is processed using cloud computing services, the Google, Amazon Web Services, and the rest of them, think through Microsoft Azure as well. So applications of data processing systems. Business, healthcare, finance, education, science, and research. For business, it's used for payroll, inventory management, and customer records. Healthcare, patient records, medical imaging, and diagnostics. Finance, stock trading, online banking, and risk analysis. Education, e-learning platforms, and student information systems. For science and research, we have data analysis, simulations, and machine learning. So a well-designed computer data processing system enhances productivity, reduces errors, and improves decision-making across industries. So now we're going to look at the procedures for computer and data preparation method. This will commence when we come back from break. Like I said earlier, I'll take questions from what we've talked about so far, and then we'll jump into this when we get back. Edith, over to you. Thank you very much, everyone, for listening, and see you after the break.
All right, thank you very much, Mr. Usman. You have really taken it from the basics. And for those who mentioned earlier that they are beginners, your competency level is 1, 2. I hope we've been able to build for you from the beginning, mostly from like from the scratch, and the knowledge is building already. So we'll be going on break now. Before we do that, Dr. Orlando, do you have 1 or 2 things to say before we go on break? Dr. Orlando, do you have something to say? Or, okay, all right, so I guess not. All right, and we'll be coming back by 1:30, so that let's have a lunch break. We'll be coming back by 1:30 to continue. Please prepare your questions. If you have questions from what we've learned so far, we would entertain your questions before we continue for the rest of the class. So we'll see you in a bit. Please make sure you come back on time and let us start off as soon as it's 1:30. See you in a bit. Thank you, Mr. Usman. I'll see you again in a bit.
All right, you're welcome back to the class. So we stop at this point where we want to talk about procedures for computer and data preparation method. But before we go into that, as promised, before we went on break, if there are a few questions, we could quickly take them, and before we get into the next topic. I saw the other time, and someone asked me a question about data science and data analytics. So data science basically and data analytics are 2 related concepts. However, there are differences. For data analytics, for example, or data analysis, it's about understanding historical data to get hidden information, basically, through the use of statistical methods and techniques, right? So we could use tools like Power BI, SAS, SAS, and the rest of them. While data science also involves data analysis using statistical techniques. However, on top of that, for data science, you need to understand programming. You need to understand the machine learning and AI techniques. So to further uncover trends about data, that's basically it. So that's just the basic difference. Data analysis focus on understanding historical data using statistical method and techniques, while data science, you need to understand programming and computing, programming and machine learning, basically. But remember the other time, data science will help us in basically understanding trends around fraud detection and a host of other issues in day-to-day life. Any other question? Will it be safe to say that data analysis is a branch of data science? We can actually say that because data science involves data analysis as well. So any other question? So we still have a lot to cover. We need to get ahead and run fast. So I'll get ahead again, and I want to now talk about procedures for computer and data method. Can you all hear me? Please, I need response in the group chat. Procedures for computer and data preparation method. So proper preparation of computer systems and data ensures smooth processing, accuracy, and efficiency. Take note of that. Smooth processing, accuracy, and efficiency to avoid errors, because when you're processing data and there are too many errors within the data, it will not give us accurate information, and that could impact the decision or the kind of intelligence we're trying to gather for our business or any form of task we want to carry out. These are the processes and involve several key steps. In the starting point is data collection. And data collection involves identifying data sources. It's very important. And they know whether you are an expert or a beginner, and you are an intermediate data analyst or a data scientist. The starting point is how do you collect your data. And in your data collection, you must identify your data sources, which could be manual entry, sensors, online forms, and databases. So you could connect to your database, whether your Oracle database, you could Access database, it could be any other form of the database. And a lot of database around open source and also proprietary related databases. So ensure data is relevant and reliable. So at the point of data collection. And the second step is data entry and formatting. So to input data into the system, whether manual or automated, standardized format like date, currency, and text field. The third step is data cleaning and validation. So removing duplicate data, incomplete, and inconsistent data is very important. So at that point is when you clean data for us to be able to validate. So validate entry using different rules within the system. So ensuring numbers and numerics, that's data validation. And data validation could be normally so input validation as well. The input, ensuring that so that whenever people are entering data into the system, you ensure that they are consistent and in line with the data type that is expected to be input into the system at that particular instance. So the first stage is how do you store your data storage and organization of your data. So saving data in a structured manner, whether in your databases or spreadsheets. So implement proper indexing. So indexing should ensure that you are able to arrange the data in a format that at least when you put a primary key information or fine naming convention, you're able to identify data. Recollect the other time when I talked about you visiting a medical facility and with your username, with your first name, they'll be able to get a whole lot of information about you. And that shows you data organization. And that's basically what we're talking about when you talk about data organization. So data processing. So apply necessary transformation around sorting, filtering, and calculation. So how do you sort your data? A lot of you are used to Microsoft Excel, basically, to use Excel, SQL, Python, and data processing application. So around sorting, filtering, and calculation. So 6 steps is data security and backup. After you've done all of this, you must ensure data is secure and back it up, because there could be a form of failure. In the event that the data is unavailable or something happened, you should be able to fall back or roll back. No, not roll back in this case. You should be able to have another copy somewhere that you could fall back to. That could be like a backup for you in case your primary data, your main data is not available. So another copy, just like another copy, let's put it that way. So how do you ensure your data is secure? Implementing encryption, access control, and authentication. So these are the basic steps. There are a lot more which we'll talk about them as we make progress. So regularly back up your data, whether you want to, and it depends on your decision. It depends also your resources that's available to you, because everything comes at a cost as well. So do you want to back up in the cloud, like we talk about Amazon? You want to back up in the Azure or your Google, and a whole lot of other cloud service providers that are available? Or you just want to back up using an external drive or tapes, depending on your business and depending on the criticality and the amount of data. So you want to back up in drive, or you keep within your location, or you want to determine an offsite location where you want to keep such backup. So the 7th step is data output and reporting. So how do you generate report? Because the essence of all of that is to be able to make sense, get insights from the data that you have processed. So generating report visualization, diagram, graphs, infographics that you can also export in PDF format, CSV, or Excel format. So review and feedback. Analyze process data for accuracy and insights. Make adjustments as necessary. And following this structured procedure, ensure data is accurate, data is secure, and ready for effective decision making. Remember, the starting point is identifying the source of data. It's very important. Now, we'll move on to security and safety procedures within a computer environment. Remember, you're building up, you set up your system, you're ready, analyzing, you've installed software. How do you ensure secure and safety practices within a computer or a computing environment? Safety and security procedures in a computer environment. Ensuring security and safety in a computer environment is essential to protect data, systems, and users from cyber threats, unauthorized access, and accidental damage. Underlined, to protect your computer environment, your data, which is stored on your system, to protect that system and the users of the system from cyber threats, unauthorized access. The people that do not have the right, they have nothing to do. Generally, in computer security, we say that access must be given based on need to know, based on what your job function, based on need to know or need to do, basically. So need to do could be your job function, or you need to carry out something, or you need to get hold of a particular information. You need to have access, whether you are an auditor, whether you are the MD, whether you are the manager, or you are your staff, or you're even the user. So to prevent from unauthorized access and accidental damage as a result of ignorance or lack of skill. So below are the key procedures and best practices. So first is the physical security. Whether your computer is in a location, whether it's in a room or it's an office or anywhere you put it. So the starting point is to physically secure that location where your data is stored or where your system resides or is located. So restrict access, use the use of ID badges, your ID cards, or some sort of card that grants you access into that facility. Biometric authentication, whether through your fingerprints or palm vein or any form, or even your iris or authentication or security codes, could be 123 or 99999 for access into the computer room. So that's restricting the use of people that are going in and out of that facility. If they don't have business there, they shouldn't be there. Remember, access must be given based on need to know or need to do. So secure hardware. So how do you now secure the hardware? So lock computers, servers in secure location to prevent theft or any form of tampering. To physically prevent the computer being taken out of that facility or theft of some sort of hardware or any form of peripheral that is attached to that device. It could be keyboard, it could be mouse, any other device that is attached to that computer. Install surveillance through CCTV cameras, security alarms to help monitor and protect sensitive areas. Use surge protectors to prevent damage from power surges and power failures. These systems or computers are being powered. So apart from the fact that we want to secure physically, you want to put surveillance, you must also ensure that the power source that is feeding that equipment is also clean power in a way, and you must ensure that it's protected through surge protectors and the UPSs to ensure that to avoid failures. The second step in cybersecurity measures through the use of strong passwords, create complex password. Like we talk about password a lot. Mix use of letters, numbers, and symbols, and change them regularly to enable multi-factor authentication in terms of, apart from your password, another level of authentication. And there are several levels of authentication you could use. And when you talk about authentication, you talk about what you know, which is basically your password. What you have, it could be your hardware token device, and what you have, some sort of your biometric or authentication. And so combining all of these forms of authentication is what we're saying when we talk about enabling multi-factor authentication. So install and update antivirus software. Every system is expected to have an up-to-date antivirus software to prevent malware, ransomware, and viruses. So to keep software updated as well, your system, whether your operating systems or system application. Remember, we talk about software. We talk about system software, we talk about application software, and programming software, and other forms of utilities. All of this software must be kept updated. Patches must be kept up to date to avoid security vulnerability, because any form of vulnerability could be exploited by threats. So use firewalls, prevent unauthorized access by filtering incoming and outgoing traffic, permits, or access. Like I talked about the other time, all of these devices, they have rules, set of rules. The firewalls have rules to either permit some sort of traffic, incoming or outgoing. So the third one is data protection and privacy. So encrypt sensitive data, protect data from being read by unauthorized users, implement data backup strategies in terms of regular backups to help recover data in case of loss. That's the major reason why we have to back up in case of data loss, in case of data theft, or in case of accidental damage of data. Secure network connection using VPNs, the virtual private networks, and secure Wi-Fi network with WPA3 encryption method. Before it used to be WPA2, but because of the inconsistencies in WPA2 encryption, WPA3 encryption is the most secure form, one of the most secure forms of encryption method we have now. So control access levels. So grant permissions based on user roles, access in terms of your role within the organization. Like I said, I'll continue to emphasize this. Based on what you need to do, access should be given based on need to do your job. Access should not be given just endlessly. Should not be granted all the access. You must not have access. People in the organization is that they are admin, they are the employee. Such people they are a risk to such an organization or to that environment. So admin, employee, or guest access must be segregated and must be properly defined. And those rules and policies also must be in place to ensure that these access levels are granted. So follow data protection regulations. It's very important. All of these regulations are important to avoid fines, sanctions, or forms of penalty, like ensuring compliance with laws such as GDPR, General Data Protection Regulation, HIPAA, Health Information Portability and Accountability Act, if I'm still correct, or any other form of regional cybersecurity laws. To save internet and email usage. Excuse me. We must ensure that we use our internet safely, and our email usage must also be safe as well. And taking into consideration these three areas, we must be aware of phishing scams, avoid clicking suspicious links and attachments in emails. Emails such as, hooray, oh, today is your birthday, accept your gift. All of those things, email must be very suspicious of them. And we must also be careful. Like, before you click, you must think, stop, think, connect. You must stop, think before you connect. Use secure website, check for HTTPS in URLs before entering your personal or financial details. Ensure that that site is an HTTPS site before you connect. Avoid public Wi-Fi for sensitive work, particularly when you're carrying out your financial transaction or your banking transaction. Are you with me? Please, I need a response in the chat box. All right, thank you very much. System monitoring and incident response. Monitor network activity, identify and respond to suspicious behavior, establish an incident response plan, having a strategy for handling breaches, data loss, or cyber attacks. You must have an incident response, just like things that happen globally, whether it's flood, whether it's environmental problem, whether it's fire, there has to be an incident response plan. The facility where you keep your computers or where you put your servers, things will happen. There could be a flood, there could be a fire outbreak, there could be like a breakdown, there could be building collapse. So how do you get back to business? And that's it. To ensure that you minimize the downtime or any form of service interruption. So there has to be an incident response plan in place, which is part of the activity when we're talking about system monitoring and incident response. Conduct regular security audits to check or identify potential security gaps. Even despite the fact that you put security guards around your house or anywhere, you still have to go around, check the fence, or you have your electric fence, you have your wires, you have cameras everywhere. At times, you have to also ensure that you check to find out where are the loopholes, what are the point of entry or point of exiting which attackers or enemies could break into such an environment. And ditto for when you talk about building systems or protecting your systems, you must ensure that you regularly do audits to check and identify potential security gaps. Employee awareness and training, very, very important. This is about educating users on cybersecurity best practices, regular training on security threats and how to avoid them. Create clear IT policies on the line. It's not about downloading a draft policy online and throwing it into the environment. It has to be policies that meet the need or the intention or the objective of that organization in terms of business and security objectives. So setting rules for password management, software downloads and data sharing, report suspicious activity. During security awareness training, users are encouraged to report security risks immediately. So there has to be a channel where incidents are reported and actions are taken immediately. Disaster recovery planning. There has to be, must develop a recovery plan. This is as part of safe and secure practices in a computer environment or in a computing environment. So define procedures for restoring system after a cyber attack or an failure. There are loads of cyber attack during COVID-19, where global systems are interrupted and services were brought down. So in situations like that, there has to be a plan to restore systems back to normalcy or back to life after such an attack or any form of failure. Test backup and recovery processes regularly. Ensure backup systems work properly. So even when you have a backup, remember we talk about data storage and backup. Even when you have a backup, you must not have a backup for the sake of having backup because the book says I must have a backup. That backup must be tested to ensure that it's working. Identify critical assets and risks. This is very important to ensure that systems are prioritized, that prioritize systems that need the most protection. So what are we trying to say here? That within an environment, there are critical assets. And there are assets. Let me start from that. These assets are classified into critical and non-critical. We must ensure that the critical assets are identified and they are prioritized and they are given the most form of protection. So a system that does not really require protection, because everything I say comes at a cost. Conclude on the security and safety procedures. So implementing strong security and safety procedures, organizations and individuals can protect computer systems from cyber threats, data loss, and unauthorized access. Regular updates, proper training, and proactive security approach are key to maintaining a safe digital environment. Now, concept of computer networks. But before I go for that, I want to ask us, and I need a response quickly through the chat box. What's a computer network? It could be one word, it could be a phrase, it could be a sentence. What do you understand by computer network? Or what's a network? Computer network, basically. I need responses from the chat box. All of us, everyone should type. Intersection of computers, Timmy. Okay. More responses, please. Something that connects between different devices. Good. Idris Saidu. Any more response? I want to be sure we're all here. Interconnectivity of two or more many computers together. Emmanuel, thank you very much. Richard Oyinloye says interconnectivity of two or more many computers. Abiodun Ariel says the connection of two or more computer devices. Anesthesia says connection of multiple computers. Good responses so far. Any more? All right. Thank you all. So go ahead. The whole idea of computer network. A computer network is a system that connects multiple computers and devices. And the whole idea is to share resources, communicate, and exchange data. You've set up all of that. Yeah. My computer, your computer, all the computers around. How would you share resources? And that's the whole idea of computer network, for them to be able to communicate and exchange data. Network can be as simple as two computers connected together, or as complex as the global internet. So components of a computer network are nodes, transmission media, network interface card, switches and routers and protocols. Nodes are devices like our computers, our servers, printers, or our IoT devices. So what's IoT? I want response in the chat box. What's IoT? So transmission media, they are wired or wireless. So this is the medium in which the network communication or computer network is established, communication happens. So wired through Ethernet cables and fiber optics, or wireless through the Wi-Fi, Bluetooth, and radio waves. Network interface card, NIC, so the hardware that connects a device to a network. All of these are components of a computer network. Switches and routers. Switches connect multiple devices, while routers manage data traffic between networks. Protocols are rules for communication, like the TCP/IP, HTTP, and FTP. So TCP is transmission control protocol. IP is internet protocol. HTTP, hypertext transfer protocol, while FTP is file transfer protocol. So these are protocols basically for rules for communication within a computer network. So what are the types of computer networks? We have the LAN, which we call a local area network, wide area network, which is the WAN. We have the MAN, metropolitan area network. We have the PAN, which is personal area network, and VPN, which is a virtual private network. Our LAN basically covers a small area like our home, school, or office, while our wide area network spans large geographical areas like the internet, while the metropolitan area network covers a city or campus. PAN is connect personal devices like a Bluetooth, a mobile, or sport, while our VPN creates a secure encrypted connection over the internet. Network topology, which is basically about how do we arrange our devices within a network. We could have a star, a bus, a ring, mesh, and hybrid topology. Devices connect to central switch or hub in a star topology, while in the bus topology, just like the bus, all devices share a single communication line. A ring topology are connected in a circular structure, while for a mesh, every device connects to every other device. An hybrid topology is a combination of two or more topologies. Permit me, please. Now, we'll talk about network communication protocols, which I talk about the other side, TCP, transmission control protocol, internet protocol. So they are standard communication protocol for the internet, TCP/IP. Please take note. HTTP, HTTPS, hypertext transfer protocol. The S is secure, which is used for web browsing. File transfer protocol, FTP, transfers file between computers. And SMTP, POP3 and IMAP, they are used for email communication. SMTP is Simple Mail Transfer Protocol. So DNS, which is Domain Name System, convert domain names into IP addresses. The domain name is www.cisco.com, www.microsoft.com is a domain name. But the DNS now convert that domain name into an IP address, could be 10.2.2.10, 10.2.2.1 or the 0 or the 2255 and all. So that's, and for anybody that wants to be a networking guru, you must understand IP addresses. Importance of computer networks. One is for data sharing, enables file and resource sharing, communication support, email, video conferencing, and messaging. Remote access, users can work from anywhere. Talk about remote work the other time. Cost efficiency reduces the need for redundant hardware. And the final one under this topic on the importance of computer network is security and backup, centralized data storage, and security management. Network security measures. Firewall is one of them. Encryption, access control, antivirus and anti-malware, regular updates, and patching. We'll talk about firewall today a lot. Basically protect network from unauthorized access. So there's some firewalls that are software-based firewall, and there are some firewalls that are hardware firewall. Definitely, but even if a firewall that's hardware-based still have software that runs on it. So encryption, secure data transmission, access control, restrict, and firewall could be as big as what we could think of. And it depends on manufacturer, but most are like, what I'm trying to say is that firewall most oftentimes they are like boxes, comes in form of a box, and where a lot of rules and protocols are set to permit or deny incoming or outgoing traffic within the network. So encryption, secure data transmission. How do you ensure that you encrypt your data through a lot of encryption methods, 3DS, AES, and a lot of them. All those are deep conversations that we will go into in the future. Access control, restrict network access based on user roles, and antivirus, protect against cyber threats. And regular patches, I talk about your system. You must patch it regularly to fix vulnerabilities within the software and the hardware system. So now understand the use of internet, the tools and resources. What is the internet? What is the internet? The internet is a global network that connects millions of computers, allowing users to share information, communicate, and access various online services. It has become an essential tool for education, for business, for entertainment, and daily life. I told people that in the past, and I still hold that belief, that the basic necessities of life today, then in our primary school, I was taught that the basic necessities of life are food, shelter, and clothing. But today we need to add the fourth one, which is the internet. It's an essential tool today that we cannot live without. But it's important as a student of computer science and software and cybersecurity to understand that the internet does not forget. What you share, you must share information securely. You must not overshare information on the internet, because internet never forgets. Uses of the internet. The internet provides numerous functions, including communication through our email, messaging apps, video calls, and social media. Information research, search engines, online libraries and ebooks, business and e-commerce, online shopping, Alibaba and the rest, banking, remote work, education and e-learning, online courses, virtual classrooms, research tools, entertainment, streaming videos. We'll talk about Netflix and the rest of them the other time. Gaming and social networking, cloud computing, online storage, Google Drive, Dropbox, and Internet of Things, IoT, smart home devices, and automation systems. These are the uses of internet today. Internet tools and resources. The internet is made up of several tools that facilitate activities like communication tools, email, instant messaging, video conferencing, like your our virtual meeting, Zoom, Google Meet, Skype, and our social media. All of these are internet tools and resources. And also online libraries, like the Google Scholar, ResearchGate, and Project Gutenberg. Web browsers, Google Chrome, Mozilla Edge, and Safari. They access websites and web applications. Cloud services, e-commerce and financial tools, productivity and collaboration tools, Google Workspace, M365, that's Microsoft 365, Trello, Asana, all of these are project management tools that we make use of today. Entertainment and streaming services, YouTube, Netflix, Disney, Spotify, Apple Music, and the rest of them. Safe and responsible internet use. Like I mentioned, internet is vast, and it's essential to use it responsibly and securely. Use of strong passwords protect accounts from hackers. You must ensure that your password is strong, minimum of 8 characters. You could have as much as 12 characters. You use your lowercase, uppercase, the mixture of numbers and alphabets to ensure that the password is strong and is protected from being hacked. Enable two-factor authentication, apart from your password, add an extra layer of security. Avoid clicking suspicious links. Use VPNs and secure networks. Respect copyright and privacy laws. Avoid illegal downloads, it's very important. And at this point, I want to emphasize this. We're in the era of data protection and privacy. And there are laws now that is really, really very serious that within the African continent and globally, that the EU, the AU, and the rest of the world, they are very, very strong on copyright and privacy. And as students, as professionals, as practitioners, and as researchers, we must respect these laws. Beware of misinformation. A lot of misinformation happens on social media. People share a lot. Remember the other time when we were talking about information science, the flow of information. We must verify our sources. We must not share fake news. You must verify your sources before trusting, because fake news could cause damage. I quickly give an example. A teen, I think in the United States, got an email, and that email made him to commit suicide. He got an email and made him to commit suicide. So, and such an email was sent to him, he could not verify it. And he wasn't sure where the email was coming from. So very important that we verify sources before trusting news or any form of information. Computer science and the future of society. We've talked a lot today about computers, computer science, cybersecurity, secure practices. What does the future hold? Where are we heading? As students, we must know where we are heading to properly position ourselves as experts, as students, as researchers going forward, and so that we'll be relevant now and in the future. Computer science is a foundational discipline that drives innovation and shapes the future of society. You remember we've talked about that a lot. It encompasses the study of algorithms, data structures, software development, artificial intelligence, cybersecurity, and more. So computer science is the mother of everything. As technology continues to evolve, computer science plays a pivotal role in addressing global challenges, transforming industries, and improving quality of life. Below is an exploration of how computer science is shaping the future of society. The key areas of impact. The first one is artificial intelligence and machine learning. We talk about how AI is revolutionizing industries from research to enabling innovation, predictive analytics, and decision making. So all of this application includes in healthcare for diagnosis and treatment, finance, it helps in fraud detection, and transportation to self-driving cars. Ethical considerations such as bias in the algorithms, job displacement must be addressed. Data science and big data. The ability to analyze vast amounts of data is transforming decision-making in business, government, and science. Big data is used in areas like climate modeling, personalized marketing, and public health. Privacy concerns and data security are critical challenges that as we progress, as we go further into the future, we must take all of this into consideration. Cybersecurity is the big deal. As society becomes more digital, protecting systems and data from cyber threats is essential. Advances in encryption, blockchain, and AI-driven security tools are key to safeguarding information. Cybersecurity is critical for national security, business operations, and personal privacy. So from national to business to our personal lives. Internet of Things, IoT, connect everyday devices to the internet, enabling smart homes, cities, and industries. Applications include energy management, healthcare monitoring, and industrial automation. Challenges include interoperability, security, and data management. Quantum computing. Quantum computers have the potential to solve complex problems that are currently intractable problems for classical computers. So quantum computing is coming, but most also there are also super fast computers that they have potential to solve complex problems that normal classical computers cannot solve. Applications include drug discovery, optimization, and cryptography. The technology is still in the early stages, but all the problems. A lot of research is ongoing in the area of quantum computing, and it's interesting what the future holds. Robotics and automation. Robotics transforming manufacturing, healthcare, and agriculture. A lot is happening in agriculture already. Robotics is also transforming the manufacturing industry with the advent of the fourth industrial revolution. A lot is happening in manufacturing, in healthcare and agriculture. So AI is transforming that. Automation is increasing efficiency and also raising concerns about job displacement and the need for reskilling workers and also upskilling as well. Human-computer interaction. Advances in HCI are making technology more accessible and intuitive. Innovations like voice assistants, augmented reality, virtual reality, VR, are changing how we interact with machines. Cloud computing enables scalable and flexible access to computing resources. It supports remote work, data storage, and development of AI and our IoT application. Societal transformation driven by computer science. So all of that are what future holds, and it's happening already. So where do you want to pitch yourself as a student, as a researcher, or as an enthusiast? Where do you want to be in the area of data science? A lot of jobs, big data, AI, and ML. A lot of cybersecurity. The job is IoT, quantum computing. Do you want to go into quantum computing research? All of this you need to position yourself as a student or as an enthusiast. Societal transformation driven by computer science. Okay, we cannot overemphasize this. AI, power diagnostics, telemedicine, and wearable devices are improving patient care. Genomics and personalized medicine are advancing through computational analysis, education, online learning platforms, and AI-driven tutoring systems are making education more accessible. Virtual classrooms, AR and VR tools are enhancing learning experiences. So there's no barrier to learning. There's no barrier to anything with the power of computer science and the transformation it has brought to us. Environment and sustainability. Computer science is enabling smart grids, precision agriculture, and climate modeling. AI and IoT are helping to monitor and reduce carbon emissions. Transportation, autonomous vehicles. Smart traffic systems are reducing accidents and improving efficiency. It's proven, it's done, and we can make it better. Ride-sharing platforms, electric vehicles are transforming urban mobility. Economy and work. The digital economy is creating new industries and job opportunities. Remote work and gig economy platforms are changing traditional employment models. We all agree remote work is changing quite a lot, and it has broken the barrier of broken the wall. You need to be in a particular location physically. What you need to break that barrier is your skills, and that's why what the Transformation College is providing. Social connectivity. Social media and computing tools are connecting people globally. However, there are also concerns about misinformation on the social media. We've talked about it, quite a lot of misinformation, mental health, and privacy. So how do we manage all of this with all the valuable things, with all of the communication that is happening? How do we deal with the misinformation, mental health issues, and privacy issues? Challenges and ethical considerations. Digital divide. Access to technology and the internet remains unequal, which is still there, creating disparities in opportunities. Efforts are needed to ensure inclusive access to digital tools and education across board, all the stakeholders, the government, society, individuals, and all of the professionals, practitioners. We must also come on board to ensure that we reduce the disparities in opportunities within the digital space. Privacy and surveillance. The collection and use of personal data raise concerns about privacy and surveillance. Regulation will talk about the GDPR, aim to protect your user rights, bias and fairness. AI systems can perpetuate biases present in training data, leading to unfair outcomes. Ensuring fairness and transparency in algorithms is a major challenge. Job displacement. Automation and AI may displace certain jobs, requiring workforce reskilling and adaptation. Policies are needed to support workers in transitioning to new roles. Environmental impact, the energy consumption of data centers and computing infrastructure contribute to carbon emissions. Sustainable computing practices are essential to mitigate environmental impact. It's very important. The future of computer science. Emerging technologies like the Web3 and blockchain. So decentralized system for secure and transparent transactions. Metaverse, immersive virtual environment for work, education, and entertainment. There are a lot of companies that are investing in metaverse, which is the future of computer science. And as students, we must be interested, must continue to research, ask questions, and collaborate to ensure that we build systems, we build technologies that is sustainable for the future. AI ethics and governance, developing frameworks to ensure responsible AI use. A lot of work is ongoing. A lot of work is ongoing around AI policy, AI governance particularly, to ensure that we build responsible AI for our use in the world. Interdisciplinary collaboration. Computer science is increasingly intersecting with fields like biology, medicine, environmental science. So collaborative efforts are driving innovation in areas like bioinformatics and climate technology. Education and workforce development. Expanding access to computer science education is critical for preparing the next generation of innovators. Lifelong learning and reskilling programs will be essential in a rapidly changing job environment. We must continue to learn. Learning never ends. It has to be lifelong. Especially you're alive, you keep learning so that you can reskill and upskill as well. Global challenges. Computer science will play a key role in addressing global issues like climate change, healthcare, and food security. International collaboration and open source initiative will be vital. In conclusion, computer science is the art of societal progress, driving innovation and addressing complex challenges, our day-to-day challenges, from water, environment, power, insecurity, talk about it, digital divide. So technology continues to evolve. It is essential to balance innovation with ethical considerations and ensure that the benefits of computer science are accessible to all. By fostering collaboration and inclusivity and responsible practices, computer science can help build a better future for society. This is the end of our class today. I thank you all for listening. Then we'll go to comments and questions. Thank you very much. Hello.
Hello, Mr. Usman, can you hear me?
Yes, I can hear you.
Oh, okay. All right. I was actually paying attention to doctor's class, so I'm just shuttling between both classes, and I noticed you come to the end of your class. Thank you so much. Other questions that need to be answered? Anyone with more questions? As we draw this to a successful close this afternoon. Any more questions? Please drop in the chat room. Oh, yes, we've always said this, right? The slides will be shared on the WhatsApp group, as well as the link to the class. All right. Okay, the question from Emmanuel. Okay, we have our AI program. We have AI and automation specialist course. We have AI business analyst course as well. So you might there, especially for the AI and automation specialist course, you would learn a lot of machine learning and a lot of coding, especially with Python programming language and the rest. So you might do well to register for that course, right? Any more questions? Okay. If we do not have more questions, I would like to let us know that there would be assignments. Okay. Oh yes, the AI programs run on Fridays. Last Fridays of every month, we have the AI class, right? So you could register for that program and be in class on Fridays designated for the AI course. Okay, so there would be an assignment. Emmanuel, can you drop the assignment here with the link and also share the link to the AI course so they can register, get that from the website and share so they can register for the AI program. Okay, just a minute. Okay, so Emmanuel, I've just shared the AI registration link. Please share it right here on this group. And of course, for internship, yes, I mean, we've had a number of our graduates from other programs who are doing internship with our industry partners. So yes, we are open to internship. We recommend for internship in other with our industry partners. Okay, so there's no reason to worry about that. Okay, we'll share the assignment here and also, of course, in the WhatsApp community. The presentation slides used today would also be shared on the WhatsApp community. And just an information, please, we will be migrating all the groups to Telegram because we discovered that we have reached the maximum to be as a group or for a group on WhatsApp. But Telegram is unlimited, right? So we will be moving every group, all the groups to Telegram from Monday. So please, when you get either via email or in the WhatsApp group that you belong to, if you get the link to join the Telegram group, please do click on it and migrate so we can have everybody there and carry along. Okay. Mr. Usman, I think you have a question. Okay. Adekule is asking, during the lecture, you mentioned that fifth generation is the last generation of computers. I have a Lenovo ThinkPad with Core i5 8th generation. Does that count? Okay. Mr. Usman, are you still on board? Are you still on board? Okay. Mr. Usman, you can speak up so we can hear your response. We can't hear you, Mr. Usman.
Hello, can you hear me now?
Okay, good. Yes, I can hear you.
So you mentioned that the fifth generation is the last generation computer. I have a Lenovo ThinkPad with Core i5 8th generation. So if you listen clearly during the lecture, your Lenovo ThinkPad is basically not an AI enabled system. Based on the classification, we're talking about AI powered system. Let me go to the slide for you to see, because we're talking about the AI powered system that could be able to create an AI enabled application. So in that case, just so talking about the Core i5 8th generation, this one is just talking about the speed of your computer. I hope that helps.
All right. Okay, thank you for that response. Okay, so please, the assignment has been shared in the WhatsApp group. I mean, sorry, here in the chat room. You could download it, and it will also be shared in the WhatsApp community, as well as the email address to email your. Please do well down, take your assignments. Okay, Damola, I hand this over to you. Let me round with the other class. So over to you from here.
Okay, guys. What is going to happen now is that in the WhatsApp group, I'm going to be sharing all the assignments and the links and the emails for you to send your assignments to. And over the course of probably 2 weeks, we'll be expecting you have done your assignment and you have submitted it, because this is part of like your assessment, your full-time assessment for the whole course. So I would I'm trying to, okay, I will send someone is asking, they want digital marketing classroom. Everything will be sent as long as you are registered with transformation college. So you don't need to panic. You are in the right place. Occasion to get updates. All right, thank you very much.
Any other question? Is there another question? Okay.
Give you a round of applause for our coach, our lecturer today. I want to see your comments. You can type an emoji or just hello. Can anybody hear me?
All right. Okay, thank you very much, Percy. And just to add to that, please, but in the course of the new week, we will be migrating to Telegram, like it's been highlighted earlier. So if you get the link to migrate to Telegram, kindly click on it and join the Telegram group. And this is because we have reached the maximum that WhatsApp groups can accept. So we don't want to leave anybody by the window or by the doorway. We want everybody to be inside. So that's why we'll be migrating to Telegram. And so you could simply click the link and join the respective group as you get the links. Okay. So I think that will be all. Take your assignments and assessments seriously. And we'll see you again in class next week, Saturday. All right. Please be on time. And registration for this course is still ongoing, still very much ongoing. I believe you know people who would benefit from this program. Feel free to share the link with them and let them register and join us in class next week, Saturday. So thank you very much, everyone. Have a beautiful, beautiful weekend. Stay happy and stay blessed. Bye for now.